Hello you guys. Here's your lesson for section 6.5, Conditions of Special Parallelograms. Miss C. McCarthy, Okemos High School math instructor. In this particular lesson, we're going to prove that a given quadrilateral is a rectangle, a rhombus, or a square. So this is the converse of what we did in the previous section, which you were given that it was a rectangle, a rhombus, or a square, and then you could assume certain properties were true. In this one, you're going to be given certain properties, and you have to figure out whether or not it's a rectangle, a rhombus, or a square. So one condition, or the first shape we're going to look at are rectangles. What are the conditions that need to be true in order to have a rectangle? Well, the first condition that needs to be true in order to be able to decide that it's a rectangle is that if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So the very first thing we need to know is that the quadrilateral needs to be a parallelogram, that's one, and only one angle needs to be a right angle, that's two. If those two things are true, then it's safe to assume that the quadrilateral is a rectangle. So in other words, if you have a parallelogram with one right angle, then that implies that it's a rectangle. Okay, the second condition for a rectangle would be if the parallelogram, again, has diagonals that are congruent. If the parallelogram has diagonals that are congruent, then it's safe to assume that that parallelogram is a rectangle. So here we go with that. Parallelogram with diags that are congruent implies that it is a rectangle. And then the images there help as well. Parallelogram with one right angle is a rectangle, and a parallelogram with congruent diagonals is a rectangle. Now we also have conditions for a rhombus. The conditions for a rhombus are if one pair of consecutive sides of the parallelogram are congruent, then the parallelogram is a rhombus. So one pair of consecutive sides. So a parallelogram with one pair of consecutive congruent sides. If the diagonals of the parallelogram are perpendicular, then it's a rhombus. A parallelogram with perpendicular diagonals implies a rhombus. And if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So a parallelogram with the diagonals bisecting the opposite angles is also a rhombus. So we got three conditions for a rhombus here. And then the conditions for a square would have to be the conditions for a rectangle and the conditions for a rhombus, because a square is nothing more than a rhombus rectangle. Alright, so we're going to prove one of these. Let me grab a pen here. Alright, so I'm going to draw my two columns here for my statements and my reasons. And we're going to start with the fact that we know that JKLM is a parallelogram. So we know that these sides are parallel to each other and that these sides are parallel to each other. That's because they tell you it's a parallelogram. Then secondly, we know that JL bisects angle KJM and KLM. So JL is a diagonal and it's bisecting opposite angles. So we're proving that it's a rhombus. So step one, I'm going to start with JKLM is a parallelogram. And you can use that symbol for parallelogram, and that is given. Okay, then the other thing that we're given is that JL bisects angle KLM and KJM and KLM. Oops, I put my angle there and I should be saying JL bisects angle KJM and angle KLM. So it bisects both of those. So if that's the case in the diagram, I can say that means that angle 1 is congruent to angle 2, And angle 3 is also congruent to angle 4 by definition of a bisector. Oops, I forgot my given for 2. So this is by definition of angle bisector. Okay, so we've got, let's put some markings in here. It's nice to put the markings in as you go along, so then you can tell what you're doing. If I say that this angle is congruent to this angle, and this guy is congruent to this guy. Now actually I can prove that those two triangles are congruent if I use the reflexive property. So for, I can say that JL is congruent to itself, reflexive property, and then the two triangles are congruent by, that means triangle LKJ is congruent to triangle JML by angle side angle. So if those triangles are congruent, then I can say we've got sides that are congruent. I'm going to have to go up here for my step 6. I can say that that means that JK is congruent to LM, and because we have a pair of congruent sides, a pair of parallel and congruent sides, and that is, I'm sorry, this is by CPCTC, then lastly, we can say that JKLM is a rhombus. And the reason we're allowed to say that is because we have a parallelogram with one pair of congruent sides. So that implies a rhombus. Parallelogram with one pair of congruent sides implies that it's a rhombus. Okay, so those would be the 7 steps to prove that other theorem that we had about rhombuses, about the diagonals bisecting the opposite angles. All right, so if we look at here, just to summarize, in the table below, we want to write the names of the quadrilateral that best matches the information that's checked. So we are going to choose from the list either rectangle, rhombus, or a square. So here's our little test of the conditions just to see if we're up on what we need to, of what we understand about them. So the things that are checked here for number 1 is that it's a parallelogram with one right angle. So what's the best quadrilateral that we can choose there? That one would be a rectangle. Okay, for number 2, the condition that's true is that it's a parallelogram with the diagonal that bisects each pair of opposite angles. That would be a rhombus. For 3, it has a right angle and the diagonal bisects a pair of opposite angles. So the right angle makes it a rectangle, the diagonal bisecting makes it a rhombus, so the best description for this would be a square. Here, a parallelogram with congruent diagonals. I'm thinking rectangle. Okay. For number 5, congruent diagonals and one pair of congruent consecutive sides. So congruent diagonals makes it a rectangle. A pair of congruent consecutive sides makes it a rhombus. So if we put those two together, that makes this a square. For number 6, congruent consecutive sides, that would be a rhombus. And then for number 7, a parallelogram with perpendicular diagonals, that would be a rhombus. Okay, so that's just a little check of the importance, or sorry, not the importance, of whether or not we understand what the properties are and what they dictate, what type of shape that's dictated by the properties.